The Seikan Tunnel, an engineering marvel of international significance, stands as a testament to human ingenuity and determination. It connects the islands of Honshu and Hokkaido under the seabed of the Tsugaru Strait in Japan. This monumental project overcame formidable geographical and environmental challenges and transformed the economic and social landscape of the Japanese regions. It is the world's longest undersea tunnel and even held the record as the world's longest tunnel until Switzerland's Gotthard-based tunnel opened in 2016. In this video we will deal with some history, project development, construction, costs and the wide-ranging benefits of this tunnel. And also we will try to offer a comprehensive understanding of the profound impact of the Seikan Tunnel. The concept of physically connecting Hokkaido and Honshu was first proposed during the Taisho era in early 90s, but it did not advance beyond the planning stage. A practical survey was finally undertaken in 1946 as aftermath of Japan's defeat in World War II. Namely, Japan lost considerable overseas territories and needed to accommodate many returnees. So the potential development of Hokkaido, with its vast tracts and uninhabited land and low population density, gained wide attention. Moreover, transportation institutions recognized the need for a stable transportation system between Honshu and Hokkaido, especially after the extensive damage to ferryboats caused by bombing in 1945. The Kanmon Tunnel connecting Honshu and Kyushu, completed in 1943, was the world's first full-scale undersea tunnel and have served as an inspiration for undersea tunnel construction. This actually enabled the determination of the broad tunnel alignment. The tragedy that occurred in September 1954, when 5 ferryboats, including the Toya Maru, sank in Typhoon number 15 with 1,430 casualties, highlighted the need for a safe and weather-independent transportation. From 1946 to 1955, preparatory surveys, including seismic prospecting on land and the seabed, which involved drilling the seabed, sonic surveys, submarine boring, observations using a mini-submarine, as well as geological surveys such as dredging, geophysical exploration and seabed boring, along with construction method studies, including routing tests on land, were conducted. On the other hand, the demand for transportation had been increasing steadily, reflecting the social and economic development of Hokkaido and the expanding trend of Japan's economy. Between 1955 and 1965, the volume of traffic between Honshu and Hokkaido islands, which are connected by Japan National Railway's Seikan Ferry, doubled for passenger traffic from 2 million passengers up to 4 million, and rose 1.7 times for cargo transport from 3.7 million tons up to 6.24. In March 1964, the Japan Railway Construction Public Corporation was founded, inheriting the survey-related tasks for the Seikan Tunnel from Japan National Railways. Excavation on the Yoshioka inclined shaft in Hokkaido began in May 1964 under the corporation's direct control. Additionally, excavation on an inclined shaft on the Honshu side started in March 1966. These shafts were designed to facilitate geological surveys and develop construction methods for the straight tunnel, also serving as the entrance route for the main tunnel excavation. To construct the undersea portion, it was planned to excavate a pilot tunnel and a service tunnel alongside the main tunnel. The pilot tunnel, excavated in advance, played a crucial role in conducting geological surveys and developing construction techniques. The service tunnel, excavated parallel to the main tunnel, not only facilitated drainage and ventilation, but also shortened the overall construction period. The service tunnel was periodically connected to the main tunnel with a series of connecting drifts at 600 to 1000 meter intervals. 2 stations were built within the tunnel, Tapi Kaitei Station and Yoshioka Kaitei Station. They serve as emergency escape points. In the event of a fire or other disaster, the stations provide the equivalent safety of a much shorter tunnel. The effectiveness of the escape shafts at the emergency stations is enhanced by having exhaust fans to extract smoke, television cameras to help route passengers to safety, thermal, infrared, fire alarm systems, and water spray nozzle. The tunnel's cross-section and gradient were designed to accommodate Shinkansen, aligning with Japan's broader efforts to develop a high-speed railway network across all islands. Excavation of the Hokkaido side inclined shaft progressed smoothly, reaching the bottom in March 1967, where the excavation of a pilot tunnel began. In contrast, the Honshu side faced challenges due to geological complexities and constant water inflow. In February 1969, a major accident occurred with water rushing into the shafts at an alarming rate. After 6 months of intensive recovery work, normalcy was restored, offering valuable insights into undersea tunnel construction. In November 1971, a groundbreaking ceremony marked the start of construction work on the main Seikan Tunnel. Engineers faced a unique challenge as the rock and soil beneath the Tsugaru Strait were unpredictable. Instead of using tunnel boring machines, workers restlessly drilled and blasted through the challenging terrain. The construction process required over 2,800 tons of explosives and 168,000 tons of steel. In 1976, a particularly challenging phase occurred when water flooded the tunnel at a rate of 80 tons per minute, but dedicated efforts overcame this setback. The Seikan Tunnel was officially opened on March 13, 1988, at a total cost of 1.1 trillion yuan, which is approximately $7 billion, which was nearly 12 times the original budget due to inflation during construction time. Taking all activities in account, construction took approximately 24 years from the start of work on the inclined shaft in the Yoshioka in 1964 until the final tunnel operation. To commemorate this achievement, the Japan Mint issued a 500 yen coin featuring the tunnel in 1988. The Seikan Tunnel features a double-track cross-section with a length of 53.85 kilometers, including a 23.3-kilometer stretch under the seabed of the Tsugaru Strait. The tunnel's track level is approximately 100 meters below the seabed and 240 meters below sea level. Initially, a narrow-gauge track of 1,067 millimeters was laid through the tunnel, but as we stated, it was designed to Shinkansen standards from the beginning, allowing for speeds of up to 250 km per hour. In 2005, the Hokkaido Shinkansen project was launched, extending the Shinkansen network through the tunnel with a 3-track rail system. 3-track rail refers to railway tracks that are usually laid with one pair of 2 rails in order to operate vehicles with different gauges, and one rail is common, and the remaining 2 are rails laid according to their respective gauges. Shinkansen services to Hakodate began in March 2016, with plans to extend the line to Sapporo by 2031. These high-speed trains operate through the tunnel, connecting Tokyo and Shin Hakodate Hokuto stations in just 4 hours and 2 minutes. Inside the tunnel, the trains reach a maximum speed of 140 km per hour, increasing to 260 km per hour outside the tunnel and 320 km per hour to the south of Morioka. As we conclude our journey through the remarkable story of the Seikan Tunnel, we invite you to embark on an even more incredible exploration of railway wonders from around the world. Join the Railways Explained channel and become a part of our growing community of rail enthusiasts. For those seeking an even deeper connection and more exclusive content, consider becoming a valued member of our Railways Explained community. As a member, you'll enjoy perks and the opportunity to engage directly with our team. You'll also be supporting us in bringing more amazing railway stories to life. Until next time, goodbye.